This is a lathe. So what we're going to talk about first in this video is the anatomy of the lathe and all the parts. It can be a little overwhelming. There's a lot of dials, there are a lot of levers. It's a machine that everyone's intrigued about, and it's a lot of fun if we can learn how to use it safely. And so let's talk about controls. And this machine and most machines are kind of split between the spindle controls and the lead screw controls. So spindle controls are up here. Behind all these controls is the spindle itself buried in this housing. The spindle is sort of the heart of the machine. This right here is 3-jaw chuck, and it attaches to the spindle, and this is the sort of work holding vise, for lack of a better way to describe it. You put your part into here, you tighten it down. The spindle assembly is what turns and spins, and then the cutter stands still and cuts into the part. Okay, so what we have to control the spindle speed, it's good to know about how fast you're going. And what we want to do is take these two nuts right here, take them off, grab this housing, and we want to identify the position of these pulleys right here, the belts right here. This setup right here, just where the belts and the pulleys are, that relationship is sort of graphically described over here. And so if the belts are towards the outside of the machine, to the left as this diagram is displayed, you're in setting 2. If they're closer to the tailstock in the machine, which is the far right, you're going to be concerned with pulley position 1. So these settings, okay? So I'm going to put this back, right? It can be a little stubborn, just work with it, kind of shove down in there. I'm going to go ahead and replace these nuts. It doesn't matter which direction they go. They can go in this way, they can go in that way. Both are appropriate. Okay, so now that we know we're in the belts are sort of to the left of the machine, that means I'm going to be concerned with 2, pulley setup 2, which are A, B, and C here, 1, 2, and 3 down. So just read it like columns and rows in a spreadsheet. So position A right here, and position 1 right here is going to give me 380 RPM. If I leave this at A and go to 2, it's going to be 1800 RPM. If I go to position 3 on this, it's going to be 1100 RPM. And it's fairly intuitive. So again, we're only really concerned with this group of numbers right here, and you just again have to ask yourself how fast you want to go. In this setup, 100 RPM is the slowest, and 1800 RPM is the fastest. Okay, so for what we're going to talk about today, let's just kind of hang out somewhere, on the low side of middle, so 500 RPM. So let's dial up B2. So the way you do that is that you can try to turn this, and you're listening for a click, but it helps to kind of take the spindle, grab the 3-jaw chuck, and rotate the spindle assembly until it goes in the click. So if I'm rotating like this and I want to go to A, you hear the click, right? And it's like shifting a standard transmission vehicle. You know when it's in gear. You can feel it. Okay, there I'm in B right there. Okay, and the same goes for this. You basically turn this until it clicks in. So that's 1. So I wanted to go to B2, so I'm going to go back. There's 2 right there. Okay, and if you turn the machine on and it doesn't spin, you obviously know this is an issue, assuming your safety's there. Okay, so let's just kind of concentrate on the spindle up and what these different buttons and indicators are. Your E-stop, probably the most important on the machine, right here. Punch it in the case of emergency. It has to be out in order to run. This is your coolant. If it's to the left, red circle, it's off. If it's to the right, green circle, it's on. You really don't need to use coolant on this machine very often. If you're going to be turning for a good finish, then you might want to consider using coolant, and it's just soluble oil. It's the same coolant that's in the bandsaw and the cold saw over there. This is a jog. So if you press this when the machine's on, you can sort of make the spindle and the lead screw assembly turn. Okay, so let's talk a little bit about the other pieces of equipment here. We've got the saddle, the cross slide, and the compound cross slide. And this is the tool post holder. This holds your carbide bits. You can also use high-speed steel blanks and shape them into any shape you want. That's a possibility. There's plenty of YouTube videos out there that'll direct you to that. Just search for grinding high-speed steel blanks. But for a learning environment like this, these carbide bits are really quite nice. You'll want a nice round carbide insert, round nose I mean, like a larger radius. What's here right now is a little tight, so it's not going to give you a very good surface finish. It's going to look like a bunch of vertical lines, almost like cutting screw threads. So the rounder it is at the nose of your insert, the finer finish you're going to get. So moving on, we have the tailstock here. Tailstock will hold a live center. It'll hold a drill chuck that you can have end mills or drills or reamers in, and you can advance that using this lever right here. There is a lockdown that won't allow you to advance it, okay? And then this other lockdown right here is how you advance the whole tailstock forward or reverse. Let's kind of work our way back down here and talk about the different dials and how we can use them. This advances the saddle about the ways of the machine. These are the bed ways of the lathe. Try not to drop anything on these. Try not to let these rust. You really want to take good care of the bed ways on the lathe. It's the surface that the saddle rides on. So if it's bumpy, the finish in your part's going to be bumpy. So that's not good. So we don't want to drop wrenches and stuff. If for some reason you find it necessary to take off this 3-jaw and put a 4-jaw chuck on, which is probably going to be discussed in the future, you want to make sure you protect the ways. Put a piece of plywood or something right here. This is very heavy. As soon as you start unscrewing these square keys here, it has a tendency to fall off, and it'll hurt if it smashes your fingers, so be careful. Here's the lead screw. Okay, behind this shroud is a lead screw. I don't know if you can zoom in on that. It's like an Allen or an Acme style screw, and for power feeding, and that is sort of controlled over here in this gearbox. But before we get there, we discussed how to move the saddle left and right along this axis. We can talk about the cross slide, which is this, and that this way and that way. And then, this is pretty self-explanatory. For your compound, you can move as well back and forth. A lot of people will set this at 30 degrees, and then it's always in position ready to go for threading. That's fine, you don't have to do that. To get the best finish, whatever axes you're not working with, you should lock down. You should lock the gibs down. In the case of the cross slide, it's this Allen wrench right here. So if you're not traveling in this direction, you can tighten this down, and that'll take chatter and give you chatter out of it, out of the assembly, and give you a better finish cut. Let's see, what else? We can talk a little bit about the power feed option here. Just like in most lathes, there are little diagrams to kind of indicate your power feed options. Right now, if I were to press down, that indicates that we're going to move the cross slide away from us and towards us when the lead screw is engaged. Middle is neutral. If I pull this way and then push up, like so, at that point, we'll move the whole saddle assembly to the right and to the left. Okay, this right here is only typically used for threading, and it's called the half nut. When it's engaged, it needs to be engaged for threading purposes. When it's not, then it's just basically neutral or disengaged. This is how you turn the machine on. You press out and down, and that engages the spindle so that it spins in a conventional cutting direction, which the spindle will spin towards you. Okay. When it's in the neutral position or in the middle position, that means the machine will be off. And when you push up, this spindle will spin away from you, and that's valuable for back cutting and using bore bars and reversing threading options and stuff like that. So we have one other option here on the floor. This is your e-stop, another version of your e-stop. If you hit this, it's a brake too. It'll make this stop spinning immediately. So for beginners, you should probably have your foot resting on that in the event that something horrible goes wrong. Okay, so then the last little bit as we're sort of making our way around this machine are the speed controls for the drive assembly on the lead screw. Okay, this chart right here, you've got basically three options. You've got threads for imperial or SAE, inch, if you want to think in terms of inch. Metric, which you'll use mostly here, is this middle graph. And this bottom third of this diagram and table is set up for basically feed speeds. So let's start here because this is the one that everyone's going to reference the most. The way this reads is that you have these two letters here and then these letters across the top. And just like the table up here on the spindle speeds, you basically have to match the letters and numbers up according to this table to achieve a speed in these one of these two triangles. So let's just pick one to focus in on, right? So this upper left, we have 0.38 right here, and then in this square, in the upper right-hand square, we have 1.392. We're talking in terms of millimeters. Okay, so that means to achieve those speeds, I would have to adjust knobs to A and D positions. So this one is knob A and B. So I'd come over and wiggle this until it engages, and then I'd do the same here. Now that's engaged, so this is set up correctly. Now I have to go over here to T and get into T. So it clicked in at T. So at this point, I can leave this in neutral and talk a little bit about what is the 0.38 reference and then 1.392 reference, these two. Why are there two numbers there? If you look at this diagram up here, that implies that anything on the bottom left is going to be referencing the speed for the cross slide. So let's look over here. That would be the same as working this right here. And then again, that would be the same as coming over, and pushing down on that, okay? So if we come back over here, the upper right indicates that's the value for the feed speed on the saddle. Again, this right here, or if I want to press up on that, there we go, just like that, that would make the saddle engage, okay? So what do the numbers actually mean? Okay, this is all about relative movement of the spindle to, or the travel speed of either the cross slide in the saddle to one turn of the spindle. So let's just say if we're talking about the cross slide, that's 0.38. That's going to be 0.38 millimeters of travel. So 0.38 millimeters of travel this direction for every full rotation of the spindle. That's how that works. So that's why they're different, because 1.392 would be referencing how far your saddle is going to move right and left. 1.392 millimeters per every revolution, full rotation of the spindle. Oh, okay. Let's see. That's good for now, and we'll kind of break this up a little bit so there's more than one video.